Alright, here we are working together to get this assignment done. So calculators are allowed but won't be needed for many of the problems. So can you solve this? The absolute value of this is less than 10. Now you could use this with your calculator and figure that out, or we can do it algebraically. So I'm going to do it algebraically for you. So to do an absolute value inequality, you write down the inequality that you see, and then you write down the inequality, and you do two things. You change the arrow, and instead of positive 10 it becomes negative 10. So for absolute value that could be positive 10 or negative 10, but for an inequality we have to change the sign when we put in negative 10, and then you solve it. So to solve this, we're going to add 13, and then we're going to divide. So what this answer says is it's bigger than 3 over 2, which is like 1.5, but it's smaller than 23.2, which is like 11.5. So we could write this in interval notation that the solutions are between 3 over 2 and 23 over 2. If I graph this, you would look at the graph and see what part of the graph is less than 10. So we know it's going to look like a V. So when it looks like a V and you find where the points of intersection is, guess what you'd find where the points are? At 1.5 and 11.5 if you used your calculator. And when is it less than? Remember, this line right here is 10. So the V is the left part, 10, like y equals 10, is that horizontal line. You find where they intersect, and then where is it below? So where's the graph below 10? So between here and here, 23 over 2 and 23 over 2. So this is what it would look like as a graph. Here's algebraically. 2, can you find the equation of a line that includes these points? So some algebra here. The change in y over the change in x. So 6 to 3 went down by 3. Negative 3 to 2 went up by 5. And then put it all together. The slope is negative 3 over 5. I'm going to take the first point, change the sign, and then keep the sign. So there's an equation that goes through those 2 points. Number 3. The graph below represents this function. You get a sketch of it. Do you know transformations just based on the sketch? So how does the graph change for different things? Transformations. So first, the negative on the outside. That means it reflects about the x-axis. So what's below becomes on top, and what's above goes below. So the first part, instead of below, is now going to be above. The part that's above will now be below. And this part that was below is now going to be above. So every part that was below is now reflected up. The part that was above is reflected below. How about the negative on the inside? Well, the negative on the inside has to do with the y-axis. So what's on the left now goes to the right. And what's this part? So we just reflected, this part gets reflected over, and then the right side gets reflected to the left. How about the absolute value bars? What do they do? Well, absolute value on the outside changes all y values to be positive. So that means if there's any part that's below the axis, we reflect that part up. So this part is above, so I write it the same way I see, but the part that went down now is going to go up. So this part that was below is now reflected up. How about the next part? The part that's below now gets reflected up. So it means the whole graph now is above. Now this one's a tricky one. When the absolute value is on the inside, again it changes all the x values to be positive. So what we do is the part to the right of the y-axis, we write it exactly the way it looks. the part to the left, we actually erase it completely. It doesn't exist. So the part to the right, it works. To the part to the left doesn't exist. And then the part you see here, you reflect it over the y-axis. So you look at the part that's to the right, draw it, then erase this part from your memory, and then what you have, you reflect over the y-axis. Done. Number 2. Write whether each one is odd, even, or neither. So how can I tell if it's odd, even, or neither? I look at the exponents on the variable. They're all even. That means it reflects over the y-axis. I look at the exponents. Now the one you don't see here is 0. 0 goes with the evens. So do you see the jambalaya here? They're all jumbled up. So this one is neither. Find the zeros of this function. Now zeros means the x-intercepts, which means you make it equal to 0 and solve for x. So we're going to factor this. The first thing I notice is that all of them have an x in common, so I'm going to factor out an x from each one. Then, even though it's not a quadratic, it is a trinomial. So I have a sense that if I use the trinomial, I could find two numbers that would factor it. So 4 and negative 5. So two numbers that multiply to 4 and add to 5 are 1 and 4, and both are negative. So when I use those numbers, which are negative 1 and negative 4, I need to be careful. So the exponent was x to the 4th. I'm going to cut that in half and use x squared instead of just x. Notice x squared times x squared, it matches. If you FOIL this, the inside matches with x squared, and the negative times the negative is positive 4. So they do match, and I took that even exponent and split it in half. Now, what's left over is called a difference of squares. So x squared subtract 1 can be written as x plus 1, x minus 1. X squared take away 4, again a difference of squares, square root, both ones, so you get x plus 2, x minus 2. So you can see all the solutions that are here. So the first factor gives you the answer 0. The next two give you positive and negative 1, and the next two give you positive and negative 2. Those are all the solutions. If I wrote the zeros as points, it would be 0, 0, positive and negative 1, positive and negative 2, and the y-coordinate is 0 every time. Turn the page. Can you find the domain and range of this? Well, it's obviously an interesting looking function. Domain, is there anything that x can't be that you can't plug in here? And the answer is yes. You can't plug in any negative number because the square root of a negative number is imaginary. And you can't plug in 0. Even though you can take the square root of 0, it leaves you with something that's undefined. So the domain actually goes from 0 to infinity, but it does not include 0. How about the range? Well, is there any way to get a 0 for an answer? No. Is there any way to get a negative answer out of this? So the square root of a positive number is going to stay positive, and the absolute value of any number is going to stay positive. So again, any positive number would be the range, but 0 is not included. So we didn't ask to graph it. I wonder if you know what that graph would look like. It's an interesting graph. If you had a table of values, you could plug in 1, 4, 9, get a sense of what the table and what it would look like. You could also use Desmos. I think it's good practice to practice something like that. All right, number 8, limits. So limits to infinity has to do with power terms when it's a rational function. So I need to know the power on top and the power on the bottom. So the power on top, I have to expand. So first, I have the big numbers in front I need to worry about. 2 squared is 4. That's where you'd probably make your mistake. 4, and the rest are 1s in front. So 4 times 1 times 1, so it's 4. And then you add the exponents when you're multiplying. And we have invisible 1s that we're adding. 2 plus 1 plus 1. So on top, the power term is 4x to the 4th. On the bottom, we don't need to do any expanding. The power term is just x to the fourth. So when the x to the fourth divide out, the answer is 4. So this limit as x approaches infinity, that's like the right end behavior for rational. We have a horizontal asymptote and it's at 4. How do I find it? Power over power. Now that works when it's approaching infinity. For negative 1, step 1 is substitution. Now when I plug in negative 1 on top and negative 1 on the bottom, it's undefined. So I need to think, is there an algebraic way to see if it's removable? So the top is factorable, a difference of squares. So x squared subtract 1 is x plus 1, x minus 1. And what I notice is the discontinuity can be removed. And once you remove it, you plug negative 1 in. Ultimately, it's just a substitution question, a limit. And the answer is negative 2. I want you to compare that to 10. Again, it's a substitution question. The challenge is that when I plug in negative 1 into the denominator, you get 0. But there's no algebraic way to remove the denominator. X squared plus 1 is not factorable, and there's no way to remove the discontinuity. And because of that, this limit does not exist. 11. Can you determine the values of a and b so that that function is continuous? So for this function to be continuous, when you plug in negative 1 to the top and plug in negative 1 in the middle, they have to equal the same answer. Now, on an AP exam, they actually want you to write it as a limit. So as x approaches negative 1 in the top, it has to equal when the limit approaches negative 1 in the middle. There's the two limit situations. Now, limit is a substitution. So where there's an x, plug in negative 1, and now you can solve it. Now, I still have two variables, but I see negative a plus b, and negative 2 take away 3 is negative 5. How about the second one? Well, I'm going to set the second one up as a limit too. So as it approaches 3 of 2x minus 3, so when I plug 3 into the middle, it needs to be the same thing if I plug 3 into the bottom, or else there's a jump, and it's not continuous. So I'm going to set it up first as a limit, and then I'm going to do the substitution. So take out the x and put in 3. And then I'm going to simplify this. So I get 6 take away 3. I get 9b. I get take away 3 plus a. I'm going to combine like terms. So I'm going to add 3 to the other side. So I have 9b subtract a is equal to 6. Not subtract a, plus a. Then I'm going to take the first equation that I just came up with, which is negative. Now I'm going to rearrange it a little bit so they line up. So the negative 5 I'm going to put underneath the 6. The b I'll put underneath the 9b. And the negative a I'll put underneath the a. So we have like terms underneath each other. They're still the same equation. But obviously you can see the a's eliminate when you add them together. So you get 1 is equal to 10b. And then when you divide, you have one answer. So b is equal to 1/10. To find the other answer, I can pick any equation and substitute in and solve it. So I'm going to choose to pick the simple one. Both of these are that simple one. So I have negative a plus b is equal to negative 5. So I want to get a by itself. So I'm going to make my life simple. I'm going to add a to the right side. I'm going to add 5 to the left side. Now when you add 5 to 1/10, they're both positive numbers, so you can just write it as a mixed number. What's 5 plus 1/10? 5 and 1/10. Simple, right? So the question was, find the values of a and b that make it continuous. And that's what we did. Number 11, can you analyze and graph a rational function? So here we have a function, and we want to be able to do different things with it. So step 1, when I have a rational, is to factor it. So the numerator, the x factors out, x squared minus 1. In the denominator, a 4x divides out, or factors out, and you're left with x squared minus 4. Again, you see the difference of squares. So you see x squared minus 1 becomes x plus 1, x minus 1. X squared minus 4, again a difference of squares. X plus 2, x minus 2. So that's a good way to start. It needs that both are helpful, expanded and factored. So what's the domain? Where does it come from? The denominator. So what are the values of the denominator that make it 0? So x can't be 0. It also cannot be positive or negative 2. All the numbers work other than that. Can you reduce it down? Is there anything removable? So the one thing that's removable is the x. And if I remove the x, I have x plus 1, x minus 1. And in the denominator, I have 4, x plus 2, x minus 2. Now, because it's removed, I'm actually going to skip right down here. That means there's a hole. So the x value, where there's a hole, is 0. And then to find the y coordinate to put on my graph, I go to the reduced form, take out the x, and put in 0. So in the numerator, if I put in 0, I get 0 plus 1, 0 take away 1. So it just leaves me with 1 times negative 1, so I know that's negative 1. In the denominator, if you put in 0, you get 4 times 2 times negative 2. That's negative 16. So a negative divided by a negative, that is barely above the y-axis. But what I recognize is 0 and 1/16 would have been the y-intercept. But instead of having a y-intercept, we now have a hole. So we have no y-intercepts because on the y-axis we have a hole instead of a point. The x-intercept comes from the numerator, so you can see it's positive and negative 1. The vertical asymptotes come from the denominator. So what are the zeros of the denominator? So that's positive and negative 2. Notice I write it with x equals to do it properly. The horizontal asymptote, the expanded form would be the easiest because we're looking for power over power. And when it's expanded, you can see it easier. So power over power, that's x cubed over 4x cubed. So the x cubes divide out and you're left with 1/4. Symmetry. So do you see odd, 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 odd? See odd, 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 odd. But yet when they divide out, right? Well, let's look at the graph to see what symmetry we see. So how do I even start this graph? Well, a good place to start are the asymptotes. So at 2 and negative 2, we have vertical asymptotes. At 1/4, so I have to just estimate where 1/4 is. There's another asymptote. We also have a hole, and the hole is at 1/16, which is just above the axes, but below the horizontal asymptote. So if this is y equals 1/4, then 1/16 is below it. That's going to help us with the picture. Now, what else do we know about this picture that would help us to understand it a little bit better? So we have intercepts. So we have an intercept at positive and negative 1. And let's start there. So if we have an understanding of this graph, we have an understanding that at the vertical asymptote, it's either going to go to infinity or to negative infinity. So what's the idea in terms of that? Also, when I look to the right, I recognize that there are no x-intercepts below the horizontal. So it can't go below to negative infinity on the right. The only place it could actually go, using the properties of rational functions, that a vertical asymptote is either going to go to infinity or negative infinity. Why can't it go down? Because it doesn't cross the x. So it has to be above the horizontal. And I know the end behavior of this. So the right end behavior is definitely going to the horizontal asymptote. And at the vertical asymptote, it's either going to infinity or negative infinity. Next step. Look to see where the asymptote came from. What's the multiplicity? So it has an odd exponent on both of them, which means that when you hit the vertical asymptote, it's going to go in opposite directions. One's going to go to infinity, and the other one's going to go to negative infinity. So I already have that. I have some things to connect here. An intercept, a hole, and another intercept. The same thing's going to happen on the left that happened on the right. See, on the left, again, it has two choices, infinity or negative infinity. See, it can cross the horizontal. But for vertical asymptote, it's either going to go to positive infinity or negative infinity. See, it doesn't cross the x-axis here. So the only place it could go here is to positive infinity, and it curves and follows the horizontal, which means on the other side it must go to negative infinity. And thinking through, without using a graphing calculator, you can get the whole picture of what we look at. Now, when I look at the picture, if I fold over the x-axis, it doesn't match. But if you fold over the y, they go on top of each other. So where is there symmetry? And the answer is, when I look off the graph, there is symmetry with the y-axis. All right, turn the page. Number 13. Can you use a piecewise and evaluate a limit? So a limit is a substitution question. So when it says 1 from the left, what piece involves 1 from the left? And that would be the top piece. So when I plug in 1 into the top piece, I get the answer negative 2. It's 1 squared subtract 3. That's where the answer comes from. 1 from the right means I plug it into the bottom piece. So if I plug it into the bottom piece, I also get the answer negative 2. Now the last one, part C. Does the limit exist at 1? Well, at 1, the value is 5. That has nothing to do with the limit. So the destination, what it is, the actual value at that, is not what we're looking at. What is it approaching? So from the left, it's approaching negative 2. From the right, it's approaching negative 2. Do they agree? Then the limit exists, and the answer is negative 2. This is not a limit question. What's the value of the function at 1? And the answer is 5. 16. It says to find each derivative below and evaluate each one at the given x value. So we're going to use some derivative rules here, whether it's the power rule, the product rule, quotient rule, chain rule, and so on. 14. To take the derivative is a simple power rule. What is that? You take the exponent, you multiply by what's in front. There's an invisible 1. So 3 times 1, and then you subtract the exponent. That's simple. 2 times negative 2, and subtract the exponent. It's an invisible 1. You don't see it, but 1 times 1 is 1. Now when you subtract the exponent, you get 0. And x to the 0 is just 1. So all you're left with is a constant, no variable anymore. And then the derivative of any constant is 0. So you don't even put that there. Oh, why do I put down negative 2? That's just confusing. So when you subtract 1, you get obviously positive 2. So let's write that again. 3x squared minus 4x plus 1. Now, if I plug in negative 2 into the derivative, what do I get? So order of operations, 4 times 3, negative times a negative, and you can see the answer is 21. 15. This is going to involve the chain rule because we have a base that we need to gets a hook from. So if we first handle the outside part first, which is the exponent. So what's in front of the parentheses, we multiply. So 5 times 1 is 5. We rewrite the base and then subtract 1 from the exponent times, now we have a hook. The base, we take the derivative of. So the base here, what's inside the parentheses, the derivative is just 3. So 3x, the derivative is 3. Negative 2 is 0. So it's just 3. And that's it. Now we can combine 3 and 5 together. So if we did that, that would make 15. And then we're going to plug in 1/3. So 3 times a third is 1. 1 take away 2 is negative 1. Now the even exponent is going to make that positive 1, so the answer is 15. 16. This derivative is going to require the quotient rule. Now the quotient rule, we're going to have a long fraction line, and we're going to follow a simple pattern. It's the bottom times the derivative of the top. So x squared, the derivative is 2x. The derivative of negative 3 is 0, so we don't include it. Subtract. Now it's the top, x squared, subtract 3, and then the derivative of the bottom. The derivative of just x is 1, and the derivative of 1 is 0. We don't include it. And then we take what's in the denominator and square it. That's the pattern of the quotient rule. Now it might be helpful to simplify it and then do the substitution. So I'm going to distribute 2x squared plus 2x. Multiplying times 1 doesn't change it, but that negative belongs to both. So that'll be negative x squared, and a negative times a negative makes it plus 3. Now, I can do one more step to simplify it. So 2 take away 1 is 1x squared. Then we have a 2x, a 3, and the x plus 1 squared. Now this one I'll answer down here. What happens when you substitute in 2? Well, this becomes a lot easier because we simplified it first. So plug in 2 for x, and we get 4 plus 4 plus 3, and 3 squared. And there's your answer. (17). This one's going to involve the product rule and the chain rule, but let's just get to start first. Now, whenever I see a radical sign, I want to make sure that it's written in a way where I can do the derivative easier. So the square root is really the exponent 1/2. And so we're going to practice that when we see a square root sign or any radical sign, that we write it as an exponent, so then the rules of derivatives are easier to apply. I want you to notice there are two things multiplying, 2x, and the second is 3x plus 1 to the 1/2. This requires the product rule to begin with. The product rule, the pattern, is actually pretty simple. It's the first times the derivative of the second. So the second, the derivative is going to be 1/2 times the 1 in front. We rewrite the base and then subtract 1 from the exponent. Now 1/2 take away 1 is negative 1/2, and we need to get stronger with fractions like that. Now we're not done yet. We still need to take the derivative of the base, and the derivative of 3x is just 3, and the derivative of 1 is 0, so it's just 3. Then we're going to add. We're not done the product rule. So what have we done so far? The first times the derivative of the second, and then the second, and we're just going to write it as a fractional exponent, times the derivative of the first, and the derivative of 2x is 2. Now we're going to clean this up just a little bit. So how do I do that? Well, notice that 2 times 1/2, that's 1, and then 1 times 3. So everything that's not inside the parentheses here becomes 3x. So 2 times 1/2 times 3. So that's 3x. I'm going to leave 3x plus 1 to the negative 1/2. Now the second part, I just have the 2, I can write that in front maybe, and I have 3x plus 1 to the 1/2. So next step is to plug in 5 and see what the answer is. So where there's an x, I'm going to plug in 5. I'm going to be aware of the negative exponent in a moment. So 3 times 5 obviously is 15. Inside the parentheses, I have 15 plus 1. That's 16 to the negative 1/2. Let's do the second one. I have a 2 in front. Again, 15 plus 1 is 16 to the 1/2. How do I continue to simplify this? Well, the square root of 16, remember 1/2 means square root. So the square root of 16 is 4. But what does the negative exponent do? It does not make the answer negative. Instead, we do the reciprocal. So the square root of 16 is 4, and the negative exponent says flip it. That's where you get 1/4. The next one is just the square root of 16. No flipping involved, it's just 4. So when I combine this together, I get 15 over 4. 2 times 4 is 8. And if I want to combine these together, I need common denominators. So 15, this is 32, over 4. And together that is, what, 47. Often, you understand the calculus, but it's the algebra, or the number sense, dealing with fractions and exponents and things like that, is what drags you back, not the actual calculus concept that we're working with. So we need to practice both. Turn the page. Find the derivative of that. And then by the limit definition, and then simplify your answer. So if I want to find the derivative using the limit definition, that's the limit as x, actually we can use h, as h approaches 0. And what we're going to do is create a slope as it approaches. Now, we have that idea that we're going to use this point x plus h. So instead of x, I put in x plus h. And then this is y2 minus y1. And then I subtract. I make sure I use parentheses. And then what goes inside is the actual function. And then in the denominator actually would have been x plus h minus x. See, it's like having 2 points, where one point is x plus h, and I plug in x plus h for the y coordinate, and the other is just x and f at x. And how do you find the slope between 2 points? It's y2 minus y1 and x2 minus x1. And that's ultimately what I did. This is just finding the slope, the change in y over the change in x, using a limit. Because the answer, if I plug in 0 for h, will give me something that's undefined, I have to do algebra at this point. So what we're doing is finding the slope at 1 point rather than at 2 points. See, these are 2 points. But if I plug in 0 for h, now they're exactly the same point. Now, when we get there exactly, we know it's undefined. But I want to know the answer as we're approaching it, not the actual destination. And that's where the limit comes in. So the denominator simplifies to just h. The numerator, I need to do some algebra. So how do I square a binomial? I'm going to remind you of the pattern again. The first term, you square it. You multiply the two together, x times h, and then double it. And then the last term, you square. We still have a minus 1. And this subtract sign goes to both. 2x squared, and the two negatives make it positive 1. It's going to start becoming easier right now. So again, it's still a limit. I still can't do a substitution. When I can substitute in and it's not undefined, then I don't have to write the limit notation. But I continue to write the limit notation until I can do a substitution and it's not undefined. So I'm going to distribute here 2 times x squared. And what do you notice on the other side? Negative 2x squared. So what do they simplify to? 0. How about the next one? 2 times 2, 4xh. Well, I don't have any like terms for that, so I write it down. How about the next one after that? 2 times h squared. Again, I don't have any like terms for that. Continue. Now the 2's we're done with. Now we have negative 1 plus 1. They cross out. So remember the negative 2x squared and the positive 2x squared, we already eliminated them. The negative 1 plus 1 eliminate. So what am I left after I distribute? Is 4xh and 2x squared. Notice I still need to write down the limit. I can't do that substitution. I factor out an h. I notice the numerator, they both have an h in common. So if I take out an h, I'm left with 4x. If I take out an h, I'm left with 2h. Now, what's going to happen is the h's divide out. Now, I can do a substitution. So, oh, dear me, dear me, dear me. Let's do it right. You're substituting not for x, but for h. So, where there's an h, you can now plug in 0. And it simplifies just to 4x. We can confirm with the power rule. 2 times 2 is 4. Subtract 1, so it's 4x. And the derivative of negative 1 is 0. So it's 4x. It matches. Good job. Number 19. Some applications of derivatives. So we have a function, and you're asked to find the average rate of change, the instantaneous rate of change of both of them. So when I have a function and I want to find the IROC, what that requires is algebra. I need 2 points. So 1 point will come from 1 and the other from 10. So I'll do that on the side. And in order to find that, I actually need to substitute in. So if I plug 1 in, 1 take away 1 is 0, and the square root of 0 is 0. Then plug in 10. So 10 take away 1 is 9, and the square root of 9 is 3. Now that I have 2 points, I can then do the average rate of change, just slope from algebra 1. So the change in y over the change in x. So that's 3 take away 0 and 10 take away 1. So if I did that, the answer is 3 over 9, or 1/3. But how about the instantaneous rate of change? That's IROC, which I do. How do I find that? Well, that's another name for derivative. So IROC means can you take the derivative, and then we're going to plug in 5 after that. So first I need the derivative. So in order to do that, I need to understand that we have a square root of t minus 1. So I need to rewrite it. I'll do that up here. Then I want to write it as t minus 1 to the 1/2. See, the derivative, the shortcuts, work with exponents, not with square root signs. So the exponent, I'm going to multiply in front, subtract 1 from the exponent. Remember, 1/2 take away 1 is negative 1/2. The hook here would be the derivative of t. That's just 1. And 1 won't change it at all. Now, what I'm going to do with that is I'm now going to plug in 5 to get the answer into the derivative. So I have 5 take away 1 to the negative 1/2. Remember, 1 times 1/2 is just 1/2. And then if I simplify this, I wonder if we can do this together, that you get 5 take away 1, which is 4. Now the square root, remember 1/2 means square root. So the square root of 4 is 2. But what does the negative exponent mean again? The reciprocal, right? Not the negative answer. So the reciprocal of 2 is 1/2. And then if I put it together, I get the answer 1/4. Number 20. The volume of a cube is this, where E is an edge length of that solid. Find the rate at which the volume is changing with respect to E. Notice not time. When E equals 10, and then show the calculus. So if I want to know the rate, that means, hey, take the derivative. And I'm doing it with respect to E, not time. So I just take the derivative I see. The exponent is 3. So 3 times 1 in front, and then subtract the exponent. And then it says, hey, take that derivative, and I want you to plug in 10. So when E is 10, what's the answer? And you get 300 when you simplify that. 10 squared is 100 times 3. We don't have any units to show what that would actually mean. But if there's units, then you'd have to make sure it's cubed divided by whatever. But anyway, the answer is 300. Turn the page. This is one of the more challenging types of derivatives, and it will be challenging throughout the course. And the more we practice, the better we'll get. If you ignore it, it's going to be on every test almost, the ability to differentiate implicitly, which means x's and y's are jumbled together. It's not explicit. It's not y equals. So we need to be able to understand the chains or the hooks that are involved when we do this. So let's do it together and make sure we understand each step as we do it. So I want to take the derivative. So to do that, to begin with, I start with x squared and y. Those are two different things multiplying. I need the product rule. It's x squared times y. The product rule is the first times the derivative of the second. Now, the derivative of y is 1, but it needs a hook, and the hook for that is y prime. See, if I'm taking the derivative with respect to x, every time I take the derivative of y, it needs the hook y prime. And that y prime is ultimately what dy by dx is. They're equal to each other. It's just easier to write y prime than dy by dx every time. And 1 times that will just be y prime. But we're not done the product rule yet. First times the derivative of the second plus the second. We're not taking the derivative of y, just the y, times the derivative of the first. Continue. Negative 3x and y. Again, a product rule. It's negative 3x times y. So the first times the derivative of the second. So we know now the derivative of y is 1, but we need a y prime hook with it. So you have y prime. Plus the second, just y, times the derivative of the first, which is negative 3. So negative 3x, the derivative is just negative 3. Next, y cubed, no product rule, just the power rule. 3 times a 1 in front, subtract the exponent, and then because we took the derivative of y, it needs y prime. I'm losing space here. And then the derivative of 10, any constant, is just 0. That's step 1, a big step. Now, what we're going to do is simplify this. And if a term has a y prime in it, it's going to stay on the left side of the equation. If the term does not have a y prime, we are going to quickly move it to the right side of the equation. So the first step, x squared times 1 times y prime. We have x squared y prime. It's staying. It has a y prime. Y times 2x is 2xy. It's going to move in a second. Next one is negative 3xy prime. It's going to stay. The next is negative 3y. It's going to move. Remember, it says y prime. And then the last one is 3y squared y prime. So, as I said, x squared y prime stays. Negative 3x y prime stays. Plus 3y squared y prime stays. So the terms that have a y prime in them, they stay. Which ones don't? Well, instead of adding, we're going to subtract it. Instead of subtracting, we're going to add it. So now we are able to rearrange this equation. Our next step is to factor out a y prime to get it by itself. So when you factor it out, what's left over? And then the last step is to divide. And this is what dy by dx equals. I just want you to notice the product rule, and every time you take the derivative with y in it, it needs the hook y prime that's hooked onto the end. Then the algebra to get y prime by itself. If a term has y prime in it, it's on the left side. If it doesn't, we move it to the right side, and then we factor out the y prime and divide. 22. Find equations of lines tangent and normal to this when x equals 1 and show the calculus. So tangent and normal require the derivative. These are perpendicular to each other. So the only difference will be the slope at the end. So we need equations. So whenever I hear the equation of a tangent line, I quickly write down x equals, y equals, and m equals. Those are the three things I need. And the question tells me x equals 1. Done. Do I know what y equals? Well, I do. And when x is 1, I just need to simplify it. So wherever there's an x, put in 1 and realize that the y value, when you simplify it, is 1/2. Not given directly, but you can plug in 1 and you can simplify it. The slope means derivative. So for me to do that, on the side, I'm going to take the derivative of this. You can see the quotient rule. I'm going to do that. What is the pattern of the quotient rule to take the derivative? The bottom times the derivative of the top. So the derivative of x is just 1. Minus. Keep going. The top times the derivative of the bottom. So the derivative of x is just 1. And then the bottom squared. So there's the pattern. I'm not going to simplify this just to make it a little bit easier. X plus 1 times 1 is just x plus 1. X times 1 is just x. And then the bottom, I'm not going to mess with it. X take away x is 0. So really, I just have this left over for the derivative. So to find the slope, I use the x value. So when you plug in 1 for x, what do you end up with? Is you get 1 plus 1, which is 2, and you square it, and you get 1/4. These are the numbers I'm going to use. Tangent, I use what I see. 1/4 is the slope, and then you change the sign for x, keep the sign for y. Done. The only difference between tangent and normal is that they are perpendicular. Perpendicular slopes means you do two things. First, change the sign. Opposite, reciprocal. Positive becomes negative, and the second is you do the reciprocal. So it's -4, and then the rest is exactly the same. 23. And any time you need a break, you press pause and continue it when you're ready. Find the equation of the line tangent to this curve that are parallel to this. I want to find the equation of a tangent line. I write down x equals y equals m equals and see what I know and what I don't know. Do I know the x value? No. Do I know the y value? No. So I don't know x and I don't know y. But do I know the slope? Parallel means the same slope. So the slope of this line is 1/3. That's the slope I'm using. So how will I then find x or y? Well, tangent line means derivative. And if it's the derivative, I start there. What's the derivative of that? X to the 2/3. Use the power rule. 2/3 times 1 is 2/3. Subtract 1. Can you go 2/3 subtract 1? Think the denominator. The denominator is 3. So 1 becomes 3/3. So 2 take away 3 is -1/3. That's the exponent. Now how am I going to do this from this step forward? Well, the derivative means the same as the slope. I know the slope, so I can make them equal to each other. And now I'm going to solve for x. So to make my life a little easier, to solve this, I see the fractions. Multiply everything times 3. The 3's will cross out on both sides. The next thing I notice to get x by itself is I can divide by 2. And then do you remember that negative exponent? What this negative exponent means? It means the reciprocal. So that means it actually belongs in the denominator and it's no longer a negative exponent. Do you see how the numerators are equal to each other? Well, then you can just make the denominators equal to each other. The last step to get x by itself, what undoes that fraction is the power. The reciprocal would undo it. So that actually means cube root. So a cube undoes this. Notice the 1/3 and the 3, they would cross out and leave you just with x to the 1, which is x. And on the other side, when you do the same to the left side as you did to the right side, 2 cubed is 8. 2 times 2 times 2. So now we have the second piece to the puzzle. 8. Well, the last piece will be simple. Because now that I know what x is, I go back to the equation and I plug in 8 for x, and I evaluate it. How do I evaluate a fractional exponent? I'll tell you. The denominator is the root. So what root do we have if it's the denominator? It's the cube root, meaning what number 3 times itself is 8? And that answer is 2, because 2 times 2 times 2 is 8. So I evaluated the denominator first. Then I have the numerator still, and I do what it says. 2 squared, which is 4. So now I have the x value, the y value, and the slope. So what's the equation of the tangent line? Start with the slope, change the sign, x minus 8, keep the sign, plus 4. Done. Turn the page. Last one. And again, if you need a break, take a break and then come back and then finish the assignment with me. 24. Here we have an equation, and you're asked to find the velocity, acceleration, and so on. So this is a position equation. If I want to know what the position is after whatever it is, t equals 1 or 3, whatever, you plug that number in, it'll tell you what position, where it is. But if I want to know the velocity or the acceleration, what do I do with the position equation? And the answer is, I need to take the derivative. So to find the velocity, I take the derivative of the position. And the derivative of t squared, 2 times 1 in front, is 2t. And the derivative of negative t is just negative 1. The derivative of negative 2, well, that's 0. I don't include it. Keep going. How do I find the acceleration? It's the derivative of the velocity. So the derivative of this, the derivative of 2t, is just 2. And the derivative of negative 1, well, that's 0. So we have an equation for velocity, an equation for acceleration, and an equation for the position. All 3 that we need. So part C, the values of t for which the particle is moving left, and justify your answer. We know when the velocity is negative, it means it's going left. But in order to understand that, we actually need to know when the particle is at rest, so we can understand left or right from the rest. So to understand when it's at rest, we take the velocity and make it equal to 0, and we solve it. We add 1, we divide by 2, and at what t value is it at rest? 1/2. Well, I am going to do a number line for the velocity. I know at 1/2 it's at rest. It's not going left or right. So from 1/2, I'm going to plug in a number that's smaller and bigger than 1/2 into the derivative and see if the answer is positive or negative. So what's an easy number bigger than 1/2? How about 1? If I plug 1 into the top, into the velocity, is the answer positive or negative? I don't even care about the value, just is the answer positive or negative? So when I plug in 1, the answer is positive. So I know after t equals 1/2, it's moving to the right. How about pick an easy number less than 1/2? Well, that could be like 0. And if I plug in 0 for t, the answer is negative. So what I've noticed is it's moving to the right after 1/2 and moving to the left before it. So when is the particle moving to the left? Well, it's moving to the left from negative infinity to 1/2. And we justified the answer by finding the derivative and by showing that velocity number line. List the values of t for which the particle is to the left of the origin. That means the position is 0, and to justify your answer. So, in order for me to understand it, I first need to know when it's actually at 0 to know if it's to the left or to the right and so on. So I need to know the position first of where we're at. So when is it at 0, then I can understand left or right. So we have a position. I'm going to make it equal to 0. So I take the position, I go, what value of t are we at position 0? Then I'm going to compare left and right above with the velocity, comparing to my answer. So I know I can answer this by factoring. The two numbers that multiply to negative 2 and add to negative 1 are negative 2 and positive 1. They multiply to negative 2, and they combine together to make negative 1t. So from the first factor, if you get the answer 2, and from the second one you get the answer negative 1. So at those times, it's at the origin. So if I did a number line for that, so when t equals 2 and when t equals negative 1, then we're at 0 on the number line. This tells me what direction the particle is going. And so I want to know when it's left of the origin. So let's first start at 2. If it's at 0 when t equals 2, everything to the right of 1/2 is moving to the right. So this particle is moving to the right after 2. So that's not going to help me. But what's happening before 2 is that it's also moving to the half to the right at 1/2. So from 1/2 to 2, it's moving to the right and getting closer to the 0. But that must mean it's to the left of 0 if it's moving to the right to get there. So I know from 1/2 to 2, it must be to the left of 0. And what's happening over here at negative 1? Well, here it's moving to the left. And so at negative 1, it's moving to the left. Remember, at negative 1, it's also going to be 0. So at 1/2, at t equals 1/2, it must be to the left as it's moving to the right to get to 0. So think of the number line. Here's the number line, here's 0. If the particle is moving to the right, it must be to the left, right, of 0. And from negative 1, it's going to return there. Now, let's think through this together. What's happening again to this particle to the left of 1/2 is it's moving left to have an understanding of it. And so just because it's moving left doesn't mean it's left of the origin to understand it. So here we are. We know that from 1/2 to 2, for sure, it's to the left. What's happening at negative 1? It came back to 0. So it changed directions and came back to 0. That means from negative 1 to 2, here it's to the left of the origin. I know it's a challenging concept. After 2, it's to the right, and to less than negative 1, it's also to the right of 0. I wish I had a better visual that you can understand this particle moving and what's happening. We know at 1/2 it changes directions. So if it changes directions, what does that mean to it? So think of the particle in terms of it being between here and here it's 0. So here and here it's to the left, and when it changes directions, it'll eventually get to the right of 0 again. I know. I already sense it. But I'll go back to the beginning. We need to understand when is the particle at 0. So the position we made equal to 0 and solved it. And then we had to have an understanding of the velocity and the position together to get a sense that this thing is going to be left of the origin between negative 1 and 2, comparing it with the velocity. All right, I'm going to move on. 25. Using your graphing calculator to find the following. And by the way, if you need proof of this, such as like this, I can make it simple that way. If you plug in a number less than negative 1 into the position, the answer should be positive. It should be to the right of 0. Maybe that's a better way to even look at it. So let's say that I plugged in a number less than negative 1, like negative 2. So if I plug negative 2 into here, that's negative 2 squared and negative 2 minus 2. when I simplify that, the answer better be bigger than 0, right? Can you see how the answer's to the right of 0? If I pick any number between -1 and 2, the answer is going to be negative. If I pick in a number bigger than 2, it's going to be positive. If I pick in a number less than -1, it's going to be positive. These give me positive answers, and in the middle, it gives me a negative answer. That negative answer means it's to the left of 0. The positive answer means it's to the right of 0. I don't know if that helped. I'm trying. Okay, use your graphing calculator to find the following. So I'm going to use our graphing calculator right here. And it says, if f at x equals that, can you find the derivative at a certain number? So let's do that together. Let me clear my calculator so you see it from scratch. So here's our calculator. And of course, my hope in this video is that you were able to check out a calculator for summer. So here we go. I'm going to press the button for derivative. Now, the best way to get to the derivative, I think, is, do you see that number 9? To the right of number 9, we have this. It almost looks like 3 squares and a little fancy parentheses. Just to the right of 9, press that button, and a whole catalog of fun calculus things come up. And then, when I look at that, I need to make sure I go to the correct button for derivative. So can you see it's already shaded what I wanted? So I need you to move the cursor so it's over what I shaded there in blue right there, and then press enter. So that's what pops up. We're taking the derivative with respect to x, and then we type in the equation, which is 2x squared subtract 2 to the exponent x. So take your time. I'll make sure there's no shine on it. Make sure you type it in correctly. Next, we're evaluating this at a number. We have a button to evaluate it and not just take the derivative. And the button is the equal sign, but I'm going to press Control first. So I'm going to press the Control button and then equal. And then what pops up are 6 possibilities. The one that evaluates is that vertical line. So I'm going to move over to the vertical line, press enter. Oh, it did not give me what I wanted. Let's try it again. So Control equal, go over to the vertical line and press enter. And then we're going to type in what we want to evaluate. Well, we want to evaluate when x equals -10. So for me to do that, the bottom of the calculator has the whole alphabet. So you just press X from the bottom. Then you press the equal sign, and then -10. And make sure you use the negative that's underneath the number 3. I can't even do that. Do it this way. So make sure that when it's negative, you use the negative underneath the 3, and not the subtract sign. Remember, the whole alphabet is here below, and I just pressed X from the alphabet. All right, that's it. Press enter. I'm actually going to press, if I want the answer to be a decimal, approximate, I press Control and then enter. If I just press enter, it'll give me the exact answer. So Control and enter. There's the answer I'm looking for. It says the 3 decimal places. So you can see you could put in negative 40.00. Now, on the AP exam, you're allowed to truncate. Means you just go 3 numbers after the decimal, and that's it. 000. But if we want to round correctly, it would be 00 and then 1. Now, we're going to use your calculator again, and it says find all the zeros. Now, how do I do that? So I make the function equal to 0, and I solve it with my calculator. So let me show you how to do that. So how are we going to solve this with our calculator? Trying to get that perfect angle so you can see it without there being a shine at all from the light. How about on this side? Oh, I see that light trying to creep in onto the calculator. All right, here we go. I want you, together with me, to press the menu button. After you press menu, I want you to go to algebra. That would be 3. Then I want you to go to solve. That would be 1. And then I want you to type the equation in that you're going to solve. So the equation is 2x squared subtract 2 to the exponent x equals 0. Oh, do you see what mistake I made? So I said equal 0. I need you to move the cursor down first and then equal 0. I don't need the equal 0 to be in the exponent with x. Now to solve it, we need to know where the comma is. So do you see on the bottom left? There it is. On the bottom left, do you see pi? That'll be helpful one day. But underneath that is the comma. I need that comma because it tells me to solve, the calculator to solve. So press the comma, and then x, and that's it. And to get the answers approximate with the decimal, I'm going to go Control and Enter, and then it's going to give me those answers. So it does give me a caution sign. That just means there's more than one answer. I need to be aware of that. To 3 decimal places. So I'm going to write these down. So one answer is negative 0.579. Another answer is 1. And then one more answer, I'm going to highlight over it and then move it to the right to make sure I see it. See how I highlighted over it and moved it a little bit? So I can see the last answer is 6.314. So there's 3 answers. I'm going to write down all 3. So one answer was negative 0.579. Another answer is 1. And another answer was 6.319. Now the 7 makes the 9 go up, so technically it's 320 if I rounded correctly. So again, if you looked at it carefully, notice the 7 makes the 9 go up, but it can't, so the 9 makes the 1 go up to a 2, so it's really 20 if you rounded it, but you could also truncate. 26, last one. Here we go. If the radius of a circle is increasing at a rate of 5 inches per second, at what rate is the area of the circle increasing when the radius is 7 inches? And it says, here's the formula for an area of a circle, like you need it. And be sure to write a complete sentence and label units. So step 1 is to write down the formula. Area is pi r squared. We are going to take the derivative with respect to time, because we have inches per second. Then we're not taking the derivative with respect to the radius, which requires a hook. All right, what does 5 represent? It's the radius of a circle is increasing at a rate of 5 inches per second. So as a calculus, that means the derivative of r with respect to time is actually 5. And because it's increasing, the answer is positive. If that word said decreasing, you'd write down negative 5. How about the 7? Well, 7 is just the radius, which is 7. Now, if at any point here there was a number that was constant, no matter over time it wouldn't change, we'd plug that in first before taking the derivative. But this circle is increasing, which means the rate and the radius is increasing over time. There's no constants here. We're now going to take the derivative. So the derivative of the area with respect to time, the derivative of pi r squared. So 2 times pi, subtract 1 from the exponent, and it needs the hook dr by dt. So a prime and r prime, it needs those hooks with respect to time. And now we do a substitution. So this is what I'm looking for. The derivative of the area with respect to time. The radius is 7. What's the rate the radius is changing? 5. I do that substitution, and that gives me the answer. So that is 35 and 2, that's 70 pi. And the unit involved, we have inches. It's area, so it's inches squared per second. So the question is, what is the rate of the circle, area of the circle increasing, right? So the circle's area is increasing at a rate of 70 pi inches squared per second when the radius is 7 inches. Done. All right, I'm proud of you that you finished the assignment with me. And keep working hard. Keep believing in yourself. I believe in you. All right? Mr. G Math. Over now.